Welcome to today's FDTD Satellite Applications webinar. Today, we're delighted to have Peter Speck from NWSWFO Quad Cities, Iowa, Illinois, join us and lead today's webinar. The title of his webinar is A Not So Elevated Supercell from Eastern Iowa to the Chicago area on 4 April 2023. Next slide. All of these webinars are recorded, so if you want to check these out afterwards, you can go to the visit web pages at this URL and check out the recording. Also, we're looking for speakers. If you're interested in leading one of these in the future, basically anything related to satellite or include some satellite and operational application, feel free to contact either Scott Lindstrom or myself, Dan Bikus, and we can get you scheduled to give a future webinar. Next slide. We'll be having about 20 minutes for our speaker, and if you have any questions, you can include them in the chat in the GoToWebinar, and we'll have a Q&A period over the phone afterwards. We'll be done by about 17:30 UTC. Just a reminder, do not press hold and mute when you're not speaking. So at this point, I will turn it over to Peter.
All right, Dan, thanks very much. Thanks for getting all of this put together here for approaching me at NWA in Kansas City last September and sharing with me all this great information. Welcome everybody, as Dan mentioned, to my presentation, a not so elevated supercell from Eastern Iowa to the Chicago area on April 4th, 2023. Before I get started, I do wanted to give a quick shout out to our Science Operations Officer, Matt Friedline, and Dave Cousins. They're both out assisting today with damage surveys from our severe weather we got yesterday. So the goals of this presentation of what I want to talk about. So first and foremost, I want to talk about the significance of this prolonged supercell. So why even talk about this? We get a lot of supercells out in Eastern Iowa and Northwest Illinois on any given severe weather season. Number two, I want to think about the challenge in recognizing a low confidence yet high impact signal. And generally the tools we use that could help us ease our confidence, put our fears at ease when forecasting these kinds of events. Number three, how many times have we been told you got to expect the unexpected? I want to go through this. This kind of gives a little bit of preview to number one. In this case, elevated supercells can at times produce severe winds, which can be significant. And then last but not least, I want to go over some messaging and warning takeaways that others could use from this event. So let's set the picture. So what happened on the morning of April 4th? The morning we had a lone supercell at first in southeast Iowa, transition gradually throughout the morning hours and into the midday hours into a family of supercells that tracked across north central into northeast Illinois. This was a pretty long event duration event as well, starting about 7 o'clock a.m. in south central Iowa and then eventually ending about 1:30 to 2 o'clock across the Chicago metro area. It was pretty big on the temporal scale, with approximately 250 miles eclipsed from west to east in its movement. And this storm-centric reflectivity loop here puts it pretty well. So you can see the supercell eventually, as it starts out in southeast Iowa, gradually transition into that supercell structure as it moves over the Quad Cities, eventually becomes a little bit less supercellular in strength. And eventually, as it moves over there, you see towards the northern suburbs of the Chicago metro area here. And I'll let this play again here for you all, just so you can see the evolution of this storm as it traverses the area. So in terms of climatology wise, these kinds of events are usually pretty common around our area this time of year. So you can see it from the research from Bunkers et al. In 2006. Generally about the April to May timeframe is when we typically get these long-lived supercell events across the area. But what I want you to take note here on the right side is the time of day. So this event, again, generally occurred across east central Iowa, eastern Iowa, northwest Illinois in those early morning hours. So generally about 12 UTC to about 18 Z. And you can see just based off of the research itself, this is not a typical event in this time frame. More or less, these kinds of events, like what we got yesterday, for example, are typically in that mid-afternoon to about early to late evening time frame. Here's a great image that just puts the scope of the magnitude, the duration of the supercell overall. So you can see we've overlaid in this green section here the track of this supercell as it moved across the area. And this supports the definition of the supercell, that quasi-steady rotating updraft definition provided in Buckers et al. 2006. But take a look overall at the motion of the supercell. You can see how it goes generally in a northeast, then to east motion, then southeast motion as it traverses across north central Illinois. Now we're going to zoom into the Quad Cities because this is where I want to really start the focus on here for much of this presentation. And it's a tale of two pictures, as you can see right now. So on the Iowa side of the Quad City Metro, so for those of you who aren't familiar with the area, we have Davenport and Bettendorf along the Iowa side. Here you can see generally a lot of large hail to significant hail reports, so about baseball sized, tennis ball sized hail. And on the Illinois side of the Quad City area, so Rock Island towards Moline, towards Kelowna, is where we got a lot of our wind reports, and then eventually our tornado reports, which I'll show you here in just a second. And here's just a couple of images of that hail. You could see that baseball hail when compared to the size of the phone there in the center, actually from one of our meteorologists here who was out for that event. And then now we get into the more interesting side of this. So going into this event, we were generally expecting a more elevated nature of storms. So that transition to a wind threat really got a lot of us here, especially when we got that 90-mile-per-hour wind gust measured at the Moline Airport around 1440 Z. That 90-mile-per-hour wind gust in tandem then produced those 4 separate tornadoes that formed on the Illinois side of the Quad City Metro. And here you can see just some of those images here that were taken from that storm survey here. Overturned semis, destroyed farm buildings. And here's a look at those tornado surveys here that were done. So 3 EF1 tornadoes and then 1 EF2 tornado that came out of this event. So why is this significant overall for us? Well, for those of you who were taking a look and following our weather out there, only a couple days before on March 31st, we had 29 tornadoes across eastern Iowa and northwest Illinois. Very, very active weather. We were still working on damage surveys, post-event follow-up, a lot of media interviews and questions ongoing from that event. And then you can imagine our faces when we're starting to see the Storm Prediction Center outlook on day 7, day 6, day 5, gradually building that severe threat across our area. And this is not usually common. You can see there on the day 5 image. This is only the 3rd time in the history of our CWA that we've had a 30% outlook 5 days out. So with our minds still going on March 31st, a lot of folks were tired. A lot of folks were tired from that event. You can imagine just how we were feeling going into it. Thankfully, though, we had a lot to build on. So we started up the messaging pretty quickly from this event, actually just before March 31st occurred. But what I want you to take note from our messaging, especially if you look there on the lower left image, was that the messaging for most of the severe weather was going to be focused on the late portions of the day and the evening. And we really focused that especially as well with the when we timed out the rounds of storms there in that image there on the lower right. And it makes sense. Looking at the paintball image here of the composite reflectivity from the HREF and its members, you can see here as we're going along, so I've highlighted the time up there on the upper right, but as we're going in towards the evening into the early morning of April 4th, you can see a lot of the HREF members are not showing a whole bunch going on. As we get towards that 12 UTC 13Z timeframe right now, you can see a couple of members like the NSSL WRF and the NAM NEST are kind of showing that evolution of potential convection moving across the area, but there wasn't a heck of a lot of agreement going on in the model guidance during that period. So the messaging was kind of a little bit tampered for the morning, mainly focusing on maybe an isolated threat with more of a buildup towards the evening. So I want to jump ship here and go into a lot of the satellite imagery here. And I want to again thank Dan for sharing a lot of this great information. And this goes into the goal number 2 here. Of looking at what could be that confidence nudge here, that builder as we go along. So let's look at the satellite imagery here. So on the left side here, we've got the low-level water vapor band imagery and the nighttime microphysics here on the right. And I know there's a lot I could go over here, but there are a couple of quick things I want you to notice here. So on the right side here, I've circled a really interesting feature that pops up northeast of the Kansas City metro that traverses northwest Missouri and then goes into south central Iowa through the morning. And you can see that feature is generally more noted on the nighttime microphysics imagery here with that little band of clouds over here. Generally, you can see it better here as this plays again, traversing right here. As that area moves in towards south central Iowa, this is what spawns the convections. You can actually see a little bit of this wave here that stretches more into northeast Missouri with an attempted convection down there, but nothing really gets materialized. It's a little bit hard to see here on the left side image, but you can really point out in these green lines here, that's the mid-level lapse rate component. We're looking at a very steep mid-level lapse rate component coming in almost 8 to 9 degrees Celsius per kilometer in that mid-level area. And that convection seems to be more focused on that tight gradient there. As we head more southeast, where that convection is trying to form, our lapse rates are much less overall. Going into the low level, mid level, and that upper level imagery for water vapor, you can really see the elevated mixed layer here showing up quite a bit. Those warm brightness temperatures that Dan shared with us here, and that was confirmed in morning soundings from our RAOB, from Omaha, and then through Topeka going further south. But you can see that convection generally forming along this wave here as it traverses south central Iowa. You can actually, what's really cool in the mid-level water vapor imagery is you can see the warmer brightness temperatures that do follow this convection as it traverses the area. Here's another really cool cross section that Dan provided to me as well. There was actually some model hinting of that potential wave as it was moving across the area. So what I want you to take note here as the animation goes along further is this rise in temperatures here at the surface and subsequent veering of wind profiles here, and as well as the increase in the mid-level lapse rates down here towards that 900 to 700 millibar component as that wave is moving across central Iowa. Going to the surface analysis here, and you can see why overall in our minds here, we're thinking more of an elevated component with storms versus surface-based. So right about 15Z, that warm front is initialized across northeast Kansas into north central and then central Illinois. Surface temperatures across eastern Iowa, northwest Illinois, given that the winds were out of the east and we're getting a lot of advecting of cool air from the Great Lakes. Temperatures are in the 40s, easterly winds, overcast stratus skies. With actually a little bit of mist as well across the area. Here's the sounding I mentioned earlier. You can see the elevated mixed layer component above 700 to about 300 millibars here, and then those subsequent steep lapse rates that follow. So our sounding measured generally in that 700 to 500 millibar layer, around 8 degrees Celsius per kilometer. We also had really effective shear as well. You can see the veering of wind profiles with height. We had a very strong jet component with effective shear generally about 40 knots or so, with pretty good mixing component generally above that very stable layer in the boundary. As we were going along and we were seeing all of these things generally before, we were really getting a good signal of the significant hail. This is what we were seeing as that storm was getting closer and closer to the Quad Cities. So as that supercell moved towards the Quad Cities, we were seeing really strong updrafts growing in height and width as it approached the area. We've plotted here one of the cross sections of our radar, and you can really see it's a bit cut off because of the closeness of the storm to the radar, but you can see those really high DBZs right above the minus 20 Celsius level. And based on local research here alone, that all but guarantees very significant hail forest. And putting it all together, I've included this image. This is from the Lincoln, Illinois radar down towards our southeast that look directly over us to the west-northwest. And you can see those high DBZs, again, well above the minus 20 Celsius line, all but generating that significant hail for us. And what we thought was really cool to throw in here was research supporting that giant hail components. And you can see these red dots here were the DBZs corresponding with those temperature lines. You could see here all but the minus 30 line was all above the 75th percentile for us, supporting that giant hail. But the big question, and the reason I wanted to do this research, was why the wind? Why, given the stable layer, the east winds providing that cool air, why did wind make it down to the surface? Because that morning sounding and that analysis would favor those storms remaining elevated and not surface-based. There hasn't been a lot of research done overall And a lot of mechanisms understood that would provide those severe winds with those quote unquote elevated storms. But thankfully, we have had some research over the last couple of years start to come out, especially within the last year from colleagues across Central Region and Colorado State University. Brett Borchardt over at the Chicago office has done a lot of elevated convection research and radar signatures and surface observations of that elevated convection associated with damaging surface winds. So here's a little bit of his research here, and this brings into the equation the gravity wave influence. So the research by Borchardt et al. has started to dive into the gravity wave component inducing damaging winds with those elevated storms. And you can see here these right side images here are just radar snapshots of some of the storms he's looked at in his case studies. So these wave pockets will often present themselves either via radar or satellite. And we saw kind of those waves in the satellite and the radar imagery. And that convection itself may be present at evenly spaced intervals. Again, a lot of that depends on the environment itself. We didn't have this showing up in our morning storm, for example. And here's just a look at a cross section of what this would generally look like. So this is the idea generally. So of course, in this situation, you have your very strong inversion layer. You have your veering of winds with height overall, and as that air approaches in the north-northeast and it encounters this strong updraft, that gravity wave will amplify. The air rises in the ascending branch and eventually decelerates and then quickly sinks in the descending branch, which is able to get through and penetrate through that strong inversion layer. And because that inversion layer is stuck just above the area, sometimes that parcel will loop up and down and around, causing those really intense downbursts at the surface. And what was also really cool from this as well, that really caught my eye was the Quad Cities ASOS data here. So you can see here in our velocity data off on the lower side here, that pronounced wind signature noted generally about 1,200 to 1,500 feet above ground level. But what I want you to take away is the data here of the ASOS on the right. So you can easily make note of when the wind comes through the ASOS. You can see the wind gust here in the gray, and then the pressure here. The corresponding pressure rises and falls with the storm. But what I want you to really make note is the temperature. So notice the temperature really doesn't change much as the storm goes through, which is atypical of storms which typically have your strong cold pool or your strong rain cooled air that accompanies the downdraft feature. So, and this is a feature you would typically, as indicated by Brett's research, this is the feature you would typically see with a storm that's more characteristic of gravity wave influence. And then lastly, putting all together here, I love this slide overall. So this is the radar cross section that puts together the the winds overall, and then shows you a lot, including the stable layer and including those winds. So up at the top here, you can see this research done by Borchardt et al. 2024 from one of the cases he took from the La Crosse, Wisconsin storms that moved through. So you can see the stable layer marked pronouncedly by those red outbounds here, and then this gravity wave indicated by the very sharp greens and blues as it makes its way towards the radar, that line of storms, all gravity wave influence. And again, a very similar pattern also noted by their ASOS data. And then you compare that to our April 4th storm here on the bottom. It's a little bit difficult here given our radar is not in the direct path of the supercell, but you can almost see a very similar signature moving through the area as the storm progresses. And I'll let this play again here for you. You can see here those inbounds going in aloft, but then this wave-like feature on the outbound side of things going by here. Again, overall indicating gravity wave influence here. That is the extent of what I wanted to present today. Here's my references sheet. Also, I wanted to thank Dan again very much for giving us the satellite imagery and taking the lead on this presentation as well. We have a lot more research to go through this event. We just presented this at the Central Iowa NWA a couple of weeks ago. We do have plans to take this more outward as we get some more research done. We have a guest speaker series coming up this summer with more information as well, but I will leave you all here with the takeaways and things just to keep in mind here as we're going through. But as of this point, I want to again thank Dan very much for organizing this presentation. And now I'll take any questions that any of you all have.
Thank you, Peter, for a great presentation. At this point, we'll take any questions or discussion points that you want to bring up. So you can either post them in the chat, or if you'd like to be unmuted and talk, just make a note in the chat and I can unmute you.
I will say this, I apologize, Dan, real quick. There are more slides to this presentation, and Dan will have these all for you all here once this is all over.
I don't see any questions yet, so I will ask. Those gravity waves, do they best show up in the 3 water vapor bands from the satellite perspective?
Yeah, we were really seeing those again in that low-level water vapor imagery. I'll go back to this really, really quickly if you'd like. Here. Yeah, here we go. So you can really see those waves pretty pronouncedly here. I'm mousing right over here, over one here as it goes across the area, and that was generally just behind this line of convection that moved across the area. But you can see more subsequent waves through the low-level water vapor imagery. And again, the presence of that elevated mixed layer here is really great in telling of those gravity waves as it moves across the area.
Right, okay. Any other questions for Peter? Okay, I'm hearing no other questions. So we can let out early here. And I want to thank Peter for leading today's webinar, and thank you all for attending today's webinar. I'll put this up as a recording here shortly, a little bit later in the day, so you can share this with others that weren't able to attend in person. Thanks, everybody, and have a great day.
Thank you, Dan, very much. Thank you, everybody.